A vector W is called linear combination of vectors v1, v2, v3 and so on till vr if it can be written in the form this W is equal to k1 into v1 plus k2 into v2 so on till kr into vr where k1, k2 and so on till kr are called the scalars. So let's see an example over here. Show that W is a linear combination of two vectors that is u and v. So according to the linear combination of vectors, from here, according to the question, we can write W as let W is nothing but k1 times of u vector plus k2 times of v vector. So just substitute the values over here. You will get it as 7 is equal to k1 times of u. But we are considering the I caps, okay? Into 1 plus k2 into 2. From here, we can write it as k1 plus 2k2 is nothing but 7. And one more equation, if we consider j caps, 4 is equal to k1 times of minus 2 plus k2 times of 5. So minus 2 times of k1 plus 5 times of k2 is nothing but 4. Similarly, if we consider k cap, minus 3 is equal to k1 times of minus 5 plus k2 times of 6. So minus 5k1. Okay, let's take this negative sign inside. It becomes plus 5k1 minus 6k2 is nothing but 3. Let's take these two equations that is 1 and 2. From here we can write it as multiply the first equation with 2. It becomes 2k1 plus 4k2 is nothing but 14. Write second equation as it is, minus 2k1 plus 5k2 is 4. Do the elimination method. This gets cancelled. It becomes 9k2 is equal to 18. From here we can get k2 as 2. Substitute this k2 in any one equation. If we substitute in 1, you'll get k1 as 7 minus 4, that is 3. To verify that these values are correct or not, from this third equation, we will prove it. Third equation, substitute both the values. From LHS, you will get it as 5, k1 is 3, 6, k2 is 2. It becomes 15 minus 12, that is 3. And RHS is also 3. Therefore, LHS is equal to RHS. Hence, we can show that the W vector is a linear combination of both U and V vectors. This is how we'll work on the linear combination of vectors.